All right, let's talk about something that drives people in manufacturing absolutely nuts. You shell out the big bucks for those premium high-end effect pigments, you're expecting this amazing shine, this incredible depth, and what you get is, well, just disappointing. Today, we're going to figure out exactly why that happens, and more importantly, how you can fix it.
I bet this sounds familiar, right? You get this perfect lab sample. The pearlescent shade is deep and shimmering, exactly what you wanted. You sign off on it. But then the parts coming off the production line look dull. They've got streaks, maybe some weird flow marks, or that metallic finish. It's all patchy, super shiny in one spot, and kind of dark and dead in another. If you're nodding your head right now, you are definitely in the right place.
So here's the thing. The root of this problem usually isn't the color itself. It's all about the effect. These premium finishes, they all hinge on one very specific principle. And once you get this, I promise, you're well on your way to mastering them for good.
Okay, so first, let's just make sure we're on the same page. We're talking about effect pigments. These are not your everyday standard colorants. They're special additives, and their whole job is to play with light to create a visual experience. Think about the shimmer on a brand new car, or the deep, lustrous finish on high-end electronics. You're not just selling a color, you're selling a look, a feel. It's a whole other ballgame.
We're going to break this down into the four main players. You've got your pearl pigments, which give you that beautiful, deep luster. Then you have metallic pigments for that classic solid metal look. And then we have the two that are notoriously tricky, the ones that cause the most headaches, silver and gold. And trust me, each one comes with its own unique set of challenges. So here it is, the absolute key to understanding all of this. The magic of these pigments comes from millions of microscopic flakes floating around in the plastic. Now think of them like tiny, tiny mirrors. When they are all lying down flat, all perfectly aligned, they reflect light in a uniform way and you get that brilliant shine. But if they're all scattered randomly, pointing in every direction, the effect is totally lost. The whole look is ruined.
Okay, let's dive in with pearl and metallic pigments. We're grouping these two together for a very good reason. Their success or failure almost entirely comes down to one single thing: the flow of the plastic as it's being molded.
And this right here, this is the before and after nobody wants to see. On the left, that's the dream, the perfect sample you approved. And on the right, that's the production reality. Dull, streaky, patchy. The crazy thing is the ingredients are identical. So what on earth went wrong?
For pearl pigments, it all comes down to this. These are tiny mica flakes, and they need to line up smoothly, almost like logs floating peacefully down a calm river. That orientation is everything. If the flow of the plastic is too turbulent, those flakes get tossed around every which way. And that's what kills the shine, giving you that dull, flat look. When it comes to pearls, flow is king.
And it's pretty much the same story for metallic pigments, which are usually little aluminum flakes. You ever see those ugly flow marks? Or notice how it gets weirdly shiny or dark right near a weld line? That's a classic sign your flakes are clumped up or misaligned. The solution here is all about control. You need to be gentle. Low shear processing is absolutely key. You want to mix them in without breaking them, and then inject them smoothly so they can align just right.
All right, let's shift gears and talk about the two divas of the effect pigment world, silver and gold. Now, don't get me wrong, flow still matters for these, but their biggest challenge is, well, they're often rooted in pure chemistry. It's about how they react to things like heat and the environment inside the machine.
And let's be crystal clear about this. Silver is, without a doubt, the single toughest effect pigment to get right. Period. There is a reason it has the highest rejection rate in the industry. If you are going to master any of these, you have to start by respecting silver.
So what does failure look like with silver? Well, you'll see three classic telltale signs. First, you might see tiny black dots peppered across the surface. That's the pigment literally degrading from heat. Second, you might get a yellowish tone, which is oxidation. It's basically rusting. And third, you can just get a general cloudy or hazy look, which means the pigment's been damaged or it's just not mixed in right.
So how do you get that perfect, brilliant silver every time? It's really this three-step process. First, always start with a stabilized grade of pigment. That's your best defense against that ugly yellowing. Second, you have to control your temperature meticulously. Overheating is silver's #1 enemy. And third, you want to keep the residence time. That's how long the plastic sits in the hot machine barrel, as short as humanly possible. Get it in and get it out.
Gold's main challenge is a little different. It's less about chemistry and more about being an artist. It's all about getting the undertone right. Achieving that rich, warm look is a very delicate balancing act.
You can see the logic right here. If your gold is looking a little bit greenish, you can cut that with a yellow undertone pigment. If it's just not warm enough, a tiny amount of red oxide will bring it to life. And for a more natural, subtle look, a hint of brown gives you fantastic control. Mastering gold is really about mastering color theory.
So, we've talked about the pigments themselves, but now we have to zoom out. Because success doesn't just come from picking the right pigment, it comes from understanding the entire system that it's a part of.
This quote right here just says it all. You have to remember, effect pigments are almost never used by themselves. They're additives. They're designed to work with a base color. And if you get that base color wrong, it doesn't matter how amazing or expensive your effect pigment is, the entire effect is just wasted.
Let's look at a few simple recipes to see how this works in practice. For a beautiful pearl white, you're not just using pearl pigment, you're adding it to a solid white base. For metallic blue, you're taking a blue base and adding in those aluminum flakes. And for that rich gold effect we just talked about, it's often a yellow base, maybe a bit of a red base, plus a pearl pigment to give it that shimmer. You have to think of the base and the effect as a team.
And the final piece of this whole system is the processing itself. This slide is so important. On the left, that's your enemy. Aggressive, high shear processing, and high temperatures. That approach physically breaks the flakes. It kills the shine. On the right, that's your solution. A gentle, controlled process. That's what preserves the flakes, allows them to align, and ultimately delivers that brilliant effect you paid for in the first place.
Okay, we've covered a lot of ground. So let's boil all of this down into a few clear, actionable rules for achieving that perfect finish every single time. Here it is, your checklist for success. First, when you're mixing, use a medium RPM. Think Goldilocks. Not too fast, not too slow. Second, during injection, keep the back pressure low. Be gentle on those flakes. And third, and this is a big one, make sure your mold is properly vented. Trapped gas creates turbulence, and turbulence will absolutely ruin flake orientation. Good venting is non-negotiable. And just as important, here are the things you should never do. Never overmix or grind the pigment, you're literally just destroying the flakes. Never, ever, ever add black to try and correct a shade. It just makes everything look muddy and dull. And finally, remember that pearl pigments are for shimmer, not for opacity. Trying to use them to hide the base color is a really common and very expensive mistake. So the final question is for you. After everything we've gone over, whether it's controlling your temperature for silver, lowering your back pressure for metallic, or perfecting that base color for gold, which one of these rules are you going to implement tomorrow to save your next batch and finally get that perfect finish you've been chasing? Thanks for watching.
Level 1 complete. You understand pigment. So far you have understood pigment, but the real game starts now. The same color in a different polymer can completely change its shade. Sometimes it's look dull, sometimes yellowish, and sometimes it doesn't match at all. If you don't understand this concept, you will have never achieved perfect color matching, no matter how much experience you have. PP, PE, ABS, nylon and PC, every polymer behave differently. And how a pro color matcher adjusts instantly, you have learned that next. The hidden chemistry of color. Color is not a surface property, it is a interactive chemical properties. In Day-12, I am going to share real industry secret that you won't find a book, only learn through practical experience. Comment right now, Day-12 ready, like the video if you found it useful, and subscribe to Secret Polymer Tag